Hello guys, welcome back to HCF class. So this is my third part in lecture 7. Okay, so in modern algebra topic. Let me read the question first. Function g from q plus. Q plus means what? Only positive rational number to set of all positive rational numbers, and so this is our given function. Positive rational number to positive rational number, and so this is what? This is our given condition, which is nothing but a composition b is equal to ab divided by 3 for all a and b belongs to given g. What is your given g here? G, which is a non-empty set, and that is nothing but q plus to q plus from q plus. Okay, so then we have to show whether, so we have to check whether this non-empty set by using this multiplication operation is a group or not. Okay, so let us check, guys. So what is our given condition? First we have to write the given condition. So that is nothing but what? A composition b. So what is our given non-empty set? That is nothing but rational number. Okay, positive rational number. So this is what? This is my given g. So next what? So next, for checking whether it is a group or not, totally 4 laws should be satisfied. Okay, so first I am going to check whether your closure law is satisfied or not in this condition. For checking a closure law, we have to take at least 2 elements. Okay, so I am going to take a, and that element belongs to my non-empty set, and as well as b should be belongs to what? G. Then what is my condition here? So that is nothing but a composition. Okay, so this is nothing but what? My binary operation, and this binary operation is nothing but here multiplication. Okay, so here a composition b, so they only gave here, so this is nothing but product of this ab, which is nothing but ab divided by 3. Okay, and this is also belongs to our positive rational number. Therefore a composition b, which is belongs to what? Q plus. Therefore here closure law is satisfied. It means what? Just to take any 2 number, like take a as a 2 and take b as a 3. I am going to take a as 2 and b as 3. Which one number you want, you can take those numbers and you can check it. Okay, so here a composition b nothing but what? 2 composition of 3. Okay, so here your a composition b, which is nothing but what is your given definition, which is nothing but a into b means what? 3 divided by 3. It means 3 ones are 3 ones are. Your answer is what? 3, and this is also belongs to what? Q plus. Okay, so this type you have to check. If you take any number and if you check this, here closure law is satisfied in this condition. So next one is what? Next one is nothing but associative law. Okay, for checking associative law, we have to take 3 numbers. Okay, 3 elements. So that is nothing but a, b, c. So here a composition b and composition of c. Okay, so here for all a comma b comma c, these all belongs to what? Q plus. Okay, so first I am going to checking for LHS. It means left hand side. So this one, a composition of b composition of c, which is nothing but what? BC divided by 3. Okay, BC divided by 3. If you do product of AB and BC by 3, your answer is what? ABC divided by 3. Okay, ABC divided by what? 3. Is this correct? No, it is not correct. Why? Because just look at here. Here you have a composition, right? Just think this is also one number. It's like a D. Okay, if it is a D, then a composition of D, which is nothing but what? AD divided by 3, right? A, D means what? BC by 3 and divided by 3. Okay, it means what? So ABC divided by 9 it is. Got it? Yes. This is simple, guys. And if you check it for RHS, you will get same here also. A composition B composition of C. First write the A composition B, which is nothing but what? AB divided by 3 composition of C. Okay, this is your one element and this is another element. So at that time A, B, C divided by, here already one 3 is there. If another 3 will come, 3 3 is a what, which is nothing but 9. Just look at here, LHS is equal to RHS, and this also belongs to what, your positive rational number. Okay, so it means here associative law is satisfied. And what is our third law, which is nothing but existence of identity law. Okay, so here I am going to take my identity element as a B. Okay, so B is what? B is my identity element. Identity element of my given set G. Okay, so then what we know, what is the condition of this identity, which is nothing but a composition of E. E means what? My identity element is B, which gives me again A, right? Yes, of course. So what is this A composition of B, which is nothing but AB divided by 3, and this is what? This is A. Okay. And so just look at here, guys. So now we have to check what is the identity element, right? So now we have to solve for B. Okay, it means what? A into 3 by A and A will get cancelled, and B as what? B is a 3. B is equal to what? Which is a 3. It means here my identity element is what in this condition? So 3 is my identity element. Okay, so now what is the last law, which is a inverse law. Okay, so what is the last law, which is a fourth one, which is a inverse law. Okay, so I am going to consider B as my inverse. Okay, so here my B is the inverse. My B is what? Which is a inverse of what? Inverse of my set. Okay, and that is also belongs to what? That should be belongs to G, such that what we know, A composition B, which is equal to at what? Identity element. What is my identity element here? Which is nothing but 3, guys. Okay, therefore, and what is A composition B? A composition B, which is nothing but AB by 3, which is also what? 3. Okay, so I don't have space here, I am going to write here. Okay, so just solve B. So B is equal to what? 3 3 is a 9, and A goes here. Okay, A goes here, and here A belongs to what? Positive rational number. A is what? A belongs to positive rational number, as well as A is not equal to 0. If A is not equal to 0, then what is my inverse element, which is a 9 by A, and which is also belongs to what? Positive rational number. Then we can say that G, it means non-empty set with respect to multiplication, is a what? Which is a group. Okay, is this easy? Yes, of course it is. Guys, you have to remembering just one thing. So here you should remembering, so first you have to read this question, whatever they might give. Okay, so in previous examples we have seen their general linear and special linear, and there we have a determinant which is not equal to 0, and determinant of A is equal to 1. Okay, if this is the condition, at that time we take the element as like this. Here this one is there, that's why I'm going to consider A is equal to this one. Okay, so next we will solve another 2 examples. So this is my second example in this video, guys. Okay, so let me read the question. So here also the group is my function, and what is this? This is Q minus. So Q minus, which is nothing but set of all negative rational number. Okay, in the example first we have seen that is the set of all positive rational number, but here it is a set of all negative rational number. Okay, and the given condition is same, but the thing is what? The thing is that here the set is change here. So now we have to say whether is this group or not. We have to check this. In the previous example, and we used the same definition, but with the set of all positive rational number, it is a group. Okay, so just now only we have solved that one. So here, is this a group? No. No, it is not a group. So why it is not a group? Why it is not a group means, so in the first condition, what is my first condition, which is nothing but closure law. Okay, so what is closure law says? A dot B is equal to what here, which is AB by 3, right? Okay, if for all A comma B belongs to the same set, then the composition of this means what? AB by 3. Okay, so this is also belong to what? Same G. G means what? So here my G is what? Rational set of all negative rational number, right? Yes. So just look at here, friends. If you take any number, okay, Q minus means what? So that set containing only a negative number. Okay, so just look at here. If I take here minus 3 and minus 2, okay, so these all are belongs to what? A set of a rational number. Minus 3 into minus 2 divided by 3. So just look at here, minus into minus what? Which is a plus. 3 2s are 6 divided by 3. 3 1s are 3 2s are. So is plus 2 belongs to the set of all rational number? No, which is not belongs to the set of rational number. Therefore, here Z with respect to multiplication is not a group, which is not a group. Okay, got it? If you have any doubt, just let me ask. Okay, let me know, I'll solve your queries. So this is my third example. So here what is there? Just look at here. So the condition is same. Okay, so the condition is same, but here the function which is start from and to. So here this is what? Set of rational numbers. Set of what? Rational numbers. Okay, so here, okay, they gave a set of rational numbers. So set of rational number means what? There it may be some numbers are plus and some are minus, and those all are things is there. Okay, it means 0 is also there and so on up to is there. But just look at here, guys. Here closure law is satisfied, associative law is also satisfied, and identity also satisfied, but it fails in inverse law. Okay, it fails in inverse law. Why it fails in inverse law means, if you take A is equal to 0, if you take A is equal to 0, then inverse element does not exist here. Inverse element means what? Which is there? Does not exist. Therefore, in this definition, only which one is satisfied? Set of positive rational number, that only gives you a group. Okay, so other than this, set of all negative rational number and set of all rational numbers, so which is not a group. Okay, if you have any doubts in these 3 examples, so just tell me in my Telegram group, otherwise my WhatsApp group, otherwise you can tell me in comment section also. Okay, so I'll provide my links of those all social medias in my description box, so you can contact me through this. And if you get any doubts or if you get any difficulties regarding this topic or any topic, so you let me know. I'll try to help for you all. Okay, I hope this video helps to you more. If you like the video, give a big thumbs up and don't forget to share and subscribe to my channel. Thank you. Thanks for watching.